Hello, check. Just a second, people. So just fixing up the camera. YouTube had logged me out exactly at 8:30 p.m. So pura login karke I just had to set things up again. Safety features for the win. Anyway, people, so what's up? How's life? I hope everything is good. Welcome to Catalysis by Vedantu. My name is Pahul, and if I'm audible and visible, please write you in the chat box. You know what to do. And the thing is, today we are going to be finishing this chapter off. So congratulations for that. So the only chapter that's remaining for physical chemistry of 12th class now would be surface chemistry. So we shall be beginning that day after tomorrow. Good, nice. So this is the question that I had given you in the previous class. It pertains to the Kohlrausch law, and I had given you all the hints that are necessary for this particular case. So Kohlrausch law says that at infinite dilution, because of independent migration of ions, you can consider their molar conductivities as separate. So infinite dilution pe molar conductivity of NaCl is as good as limiting molar conductivity of sodium positive plus limiting molar conductivity of Cl negative. This is something that we learnt in Kohlrausch law. Now over here, what's going on is for acetic acid, and in the previous class I had explained to you that alpha can be thought of as molar conductivity at a specific point divided by molar conductivity at infinity. So molar conductivity at a specific point is given. Molar conductivity at infinity can be calculated by adding these two up. That will give you the value of alpha. And once you have alpha from ionic equilibrium, we remember that Ka is equal to C alpha square upon 1 minus alpha. So these are the two equations that you were supposed to use in order to solve this question. This is the solution in case you want to write it down. So alpha comes out to be 11%, and since it is greater than 5%, you cannot ignore it in the denominator. You can ignore it in the denominator when it is 0.05 or lesser. If it is 5% or less, then you can ignore it in the denominator. Otherwise, you have to consider it in the denominator. Once you do that, this will be your answer. So now let me see how many of you gave me the correct answer in the previous class. So this is the class. Let me move myself towards the right side. Ek second. And let's sort the comments by newest first, so that the ones at the last are the oldest ones. Chalo ji. So Murli, alpha, ठीक है भाई, बिल्कुल, absolutely correct. Murli, very good job यार. Rucha, yes, that is absolutely correct. Sairam, correct. Balaji, arey yaar, I'm glad you enjoyed the classes. Thank you so much. Mohammed Sahil, okay, correct answer, but could have elaborated more, but it's absolutely fine. Good. Balaji, yes, the answer is correct. Ali, yes, that is correct. Now I hope you understand how to calculate the Ka. ठीक है. Surface chemistry we'll start day after tomorrow. Ashwin, yes, that's absolutely correct. Sangeeta, yup, correct. Lekha, your calculation of Ka is wrong. I think you have ignored the alpha in the denominator, so please don't do so. You will get the correct answer then. Lilac, that's absolutely correct. Prudvi, okay, I'll try to do that, man. Anand, yes, that is how you calculate the Ka. ठीक है, I think you've calculated it correctly. Yamini, yes, I included it now. It should be there. Pankhudi, again, I think you ignored the alpha in the denominator. Please don't ignore that. Kalpana, yes, the answer is correct. Tejeshwar, absolutely correct. Devu, हाँ वही 1 minus alpha approximately 1 नहीं करना है यहाँ पे. Venkat Sai Akshay, yes, that is correct. Good job, people. Okay, Savan and Akshat seem to have given the correct answer as well. Very nice. Chalo, Hall of Fame काफी लंबा हो गया आज. Good. So I hope you understand why you cannot ignore alpha over here, because it's not very small. Chalo ji. Now, my dear friends, today's class is about Faraday's law, and there is nothing easier than the Faraday's law in this entire chapter. The only topic remaining in this chapter is Faraday's laws and batteries. Batteries is very easy. You can read it straight from the NCERT. That's going to be your homework. Simple pieces of information will be given there. Just read about the batteries in NCERT. Faraday's law, you can read the proper statements in NCERT, but the way I will teach you Faraday's law today, you will love it, because it's so simple. You'll be like, sir, why sir? ठीक है, so ready for that? देखो, my dear friends, if you've got copper 2 positive, assume, as it's in the question, if you've got copper 2 positive needs 2 electrons to become copper, correct? Acha, if I have 2 mole copper 2 positive electrons, if I have 2 moles of copper 2 positive, do you realize it needs 2 moles of 2 electrons in order to turn into 2 moles of copper? Isn't it? Yeah. Copper 2 positive is 2 moles. It needs 2 electrons. So if you have 2 moles of copper, you need 2 moles into 2 electrons. Obviously, right? 1 copper needs 2 electrons. 2 moles of copper will need how much? 2 moles into 2 electrons. And that will give you 2 moles of copper. Ab ye 2 ki jagah, let's simply do 1 mole. Yeah, 1 mole is simpler. I don't know why I randomly took 2 moles. So 1 mole of copper will need 2 moles electrons to give you 1 mole of copper metal. My dear friends, isn't this piece of information obvious? This is Faraday's law. I'll tell you what Faraday law says, okay? Don't worry. So, ये Faraday law है basically this is Faraday law. Yeah. And how is it written in words? I will tell you in just another 5 minutes. Okay. So over here, this is 2 mole of electrons. Now let us convert this into charge. Okay. Let's convert this into charge. 2 mole of electrons, how much is the charge over here? You can do 2 into 6.022 into 10 to the power 23 into what's the charge on 1 electron? 1.6 into 10 to the power minus 19. But instead of doing this calculation, I will simply tell you 1 mole electrons have 96,500 coulomb of charge. And we've done this earlier in this chapter. Do you remember? Before Nernst equation I've told you. Okay. This 96,500 coulomb charge is also called 1 Faraday charge. Okay. So 1 mole of electrons have 96,500 coulomb charge on them, or you can simply call it 1 Faraday of charge. This F stands for Faraday. And what Faraday's law says is that 1 Faraday charge helps the reaction of 1 equivalent of a substance. Make sense? 1 Faraday charge helps the reaction of 1 equivalent of a substance. Make sense? Let's try to make sense of that statement. What will be 1 Faraday charge? 1 Faraday charge is going to be 1 mole of electrons. If I have 1 mole of electrons, it can do this reaction with half a mole of copper to give you half a mole of metal. Isn't it? That's pretty obvious. Now, what is the valency factor of copper in this case? Valency factor of copper is equal to 2, isn't it? For any redox reaction, the number of electrons involved in that reaction is the valency factor. Yeah. Number of electrons involved in that reaction is the valency factor. Valency factor is equal to 2. So 1 mole is equal to 2 equivalents. So half mole is equal to 1 equivalent. 1 Faraday is helping the reaction of half a mole of the substance, that is 1 equivalent of substance. Faraday's law is done. Thank you so much, people. Bye bye. Take care. I will go. Not really. We'll solve some questions. But all you need to understand is this ratio. That is all. Okay. There is hardly any use of the statement of Faraday's law. Faraday's law is something that is very simple, very obvious. The obvious thing is what you need to remember. Everything else is just bells and whistles. Okay. So khatam. Now let's simply solve this question. Now what we'll do is solve three to four questions. I'll give you 2 questions for homework. Chapter is done. We'll enjoy our life. Let's solve this question. I'm going to erase this. If you need the explanation once again, you can rewind it. Otherwise, just wait for the question to be solved. You'll understand this concept a little better. Okay, chalo. What mass of copper is deposited by the passage of 2 amperes of current for 482.5 seconds through an aqueous solution of CuSO4? Molecular weight of Cu is 63.5. Let's solve this question now. First things first. Charge is equal to current into time. Q is equal to I into T. This is something that you should have learned in physics, I hope. Yeah. So charge over here can be written as 2 amperes into 482.5 seconds. When you multiply this together, since we are talking about SI units, SI unit is ampere, SI unit is second, so we will get SI unit coulombs over here. So this is the amount of charge that you are passing in coulombs. Yes. अब यहाँ क्या लिखा है? What mass of copper is deposited by the passage of this? देखो सीधी सी बात है, सीधी सी बात है. Let's write it down. Okay. 2 mole electrons required, okay, for 1 mole of copper, isn't it? This is what we had understood just a little while back, because Cu has to go from copper to positive into copper. So this process will need 2 electrons here. So 2 mole of electrons are required for 1 mole of copper. 1 mole of copper can be written as 63.5 grams of copper. है ना? 2 moles of electrons can also be written as 96,500 into 2 coulombs. This charge is required for this much copper. This charge can give you how much copper? That's your question. अगर इतने चार्ज से इतना कॉपर बनेगा, इस चार्ज से कितना कॉपर बनेगा, you're done. Yeah. So from here I can write. Yeah, from here I can write 1 coulomb is required for 63.5 divided by 2 into 96,500 grams of copper, isn't it? I just took this from here to here. Just took the information from left to right. Yeah, divided by 2 into 96,500 on both sides. Okay. So how much will be the case for this much charge? Just multiply it on both sides. 2 into 482.5 coulombs is required for दोस्तों क्या आंसर आ रहा है बस ये बता दो. What's the answer coming out as? That's all you have to do. Just simple, straightforward, unitary method and you'll get the answer. Please calculate the answer and let me know what is it coming out as. फटाफट से बता दो, हो गया. Neeraj, you do whatever, you do private tuition, you do online coaching, you do whatever. If you put your effort, you can definitely crack JEE. Okay. Sairam, thank you so much, man. All right, I think Rucha and Murli are giving a very similar answer. 3.31 something aa raha hai answer, I guess. Let me check it as well. So Faraday's law is very simple. I generally don't even consider it as a separate class, but मैंने कहा चलो करवा देते हैं. I thought let's do it. 0.31 something आ जाएगा आंसर, है ना? 0.314 आ रहा है क्या? So let me try to do the calculation. ये पूरा मैं कैलकुलेशन कर ही लेता हूँ. So 2 से 2 कट गया. 63.5 into 4 at 2.5. Yeah, this divided by 96500. 0.3175. Accurately करोगे, so this comes out to be 0.3175 grams. Okay, if you do it accurately, this is what the answer will come out to be. Rajesh, this is the last class for this chapter, my friend. And this is the lecture 7. So if you're getting anywhere close to this, you're correct. I think in some approximation somewhere, you're getting that answer. But in that region, you will get the correct answer. Okay? Fine. Simple. Nothing complicated about it. Let's do the next question now. ये करते हैं. So Cr2O7 2 negative plus 14H positive plus 6 electrons. What is the quantity of electricity in coulombs required to reduce 1 mole of Cr2O7 2 negative? Yeah. Whatever happens to Cr2O7 2 negative, most likely is going to turn into 2 times Cr3 positive plus something, something, something. So your chromium 6 positive is going to turn into chromium 3 positive. One molecule of this requires 6 electrons to do so. Yeah? है ना? दिख रहा है? 6 positive to 3 positive, 3 electrons per atom of chromium. Since this molecule has 2 atoms of chromium, you need 6 electrons per molecule of chromium, isn't it? Fine. So what is the quantity of electricity in coulombs required to reduce 1 mole of Cr2O7 2 negative? Very simple. Yeah, I need 6 more electrons. 6 more electrons in coulombs is what? 6 into 96,500 coulombs. How much is this? What more do you want? Ayush, what part did you not understand in the question, my friend? Rishi, yo, what's up, man? बताइए दोस्तों, हो गया? Yeah? Simple. Nothing to worry about over here. Answer calculate कर लो, काम खत्म. Yeah? 579000 something. Yeah. ठीक है, चलो let's do the next question. What mass of nickel is deposited on cathode when aqueous NiNO3 whole twice is electrolyzed between platinum electrodes using 5 ampere current for 20 minutes? Everyone solve this question step by step. Okay? Try to solve this question step by step. You will automatically understand the Faraday's law. Okay? If there is any doubt in the initial explanation that I gave you, solve this question yourself. You will be able to do it. So what I will do right now is I will give everyone 2 minutes to solve this question. Okay, take 2 minutes to solve this question. I will go towards the side. I'll give you the entire screen. Try to solve it. If you're able to get it, great. Otherwise, I will solve it for you after 2 minutes. करके देखो. Jasima, isn't that something from physics? Bear strain, देखो Jasima, I've already taken care of that in Conformers chapter in the web series called Epic GOC. Okay, so if you watch my class of Conformers in this playlist, you just search it on YouTube, you'll be able to understand what is that Bear strain. Okay. Ayush, we've already covered almost all the chapters of class 11th as well on this channel. You can check that out in the playlists. हाँ जी, आया किसी का आंसर? अर्नव ने तो आंसर दे दिया है. I'm not sure whether it's the correct answer or not, but Arnav is giving some answer. Okay, Arnav. Okay, Arnav has deleted the answer. I don't know. And Tejaswin is now giving an answer. Everyone, please come to the answer yourself. If you're copy pasting someone else's answer, you can't do that in the examination. Yeah. चलो क्या करें? तो देखो. First, let's think about what is going on with nickel. NiNO3 whole twice. Yeah. Nitrate. Have you heard about HNO3? In HNO3, what's going on? You've got H positive and NO3 with one negative charge. Yeah. So NO3 has one negative charge. Okay, great. So over here in NiNO3 whole twice, you have nickel balanced with NO3 negative and another NO3 negative. So nickel has to have two positive charge. Simple. Now nickel 2 positive, if you have one ion nickel 2 positive, it would require 2 electrons to give you nickel. है ना जी? Same thing, you think about it in terms of moles. 1 mole of nickel 2 positive needs 2 mole of electrons to give you 1 mole of nickel, isn't it? 2 positive plus 2 electrons, nickel 0. Yeah. So 1 mole of nickel 2 positive needs 2 mole of electrons to give you 1 mole of nickel at the end. है ना जी? ठीक है. So over here I can say that 2 mole of electrons are needed for 1 mole of nickel deposition. So over here it asks what mass of nickel is deposited on the cathode when this much current is provided. Let's write this in a statement. Okay, what is the statement I can write? I can write 2 into 96,500 coulomb charge. Yeah, 2 mole of electrons is 2 into 96,500 coulomb charge gives 1 mole of nickel. 1 mole of nickel is how much? 58.69 grams. So I will write this gives 58.69 grams of nickel. We will use this statement later. Okay, from this understanding we have come to this statement. We are going to use this statement in some time. What's going on over here? We need to figure out what's the current over here. ठीक है, charge is equal to I into T. Charge कितना दे रखा है? What's the current? 5 amperes into 20. But this is in minutes. I need the time in seconds. So to convert 20 into seconds, I need to multiply it with 60. 5 ampere into 20 into 60 into seconds. So this is basically 5 into 20 into 60 coulombs. कितना आ गया ये? 5 into 20 is 100. 6000 coulomb. This is the charge, isn't it? So now you have to figure out if 2 into 96,500 coulomb gives you this much nickel, 6,000 coulomb will give you how much nickel? As simple as ABC. बताओ भैया कितना निकल आएगा? Ashish is saying it can be solved using formula also. Na sir. Ashish, it can be solved using formula also, na bro. But in examination, will you remember each and every formula? No. Use it by logic. Okay. So Ashish, that's always something that I tell. If you are good at physical chemistry, you will never need to remember any formula. If you are bad at physical chemistry, you will remember all the formulas. In the examination, you will forget all the formula. Okay. So forget about formula. Whenever you're doing physical chemistry, if you're taking the help of formula, you're doing something wrong. Physical chemistry has to be logical almost all the time. ठीक है, तो यहाँ पे सीधा सीधा करेंगे. Yeah. So simply I'll write via क्या कहते हैं unitary method itself. I'll divide this entire thing on both sides. तो यहाँ पे आ जाएगा 2 into 96500 and let's multiply both sides with 600. Sorry, 6000. So your 6000 coulombs is giving you this. है ना जी? तो भाई अब this is just about calculation. You do the calculation, you'll get the answer. Yeah. So 6 3s are 18. 180 divided by 965. 200 by 1000. 0.2 something. I don't know. Yeah. उतना ही कुछ आना चाहिए ना. What do you think, people? कुछ मिस किया क्या यहाँ पे? हमने एक जीरो क्यों कैंसिल कर दिया? Just a second. So 2 zeros are gone. So answer is approximately 2 grams. Okay, it's a very huge approximation. 16 to 3 by 1000. That's a very weird approximation that I'm doing. 60 into 3 by 1000, 1.8, अप्रोक्सीमेटली 1.8 ही आना चाहिए वैसे देखा जाए तो, 1.8 grams. हाँ ठीक है. Yeah, people are saying 1.825. Okay, that's fine. Cool. Simple, isn't it? I don't think I need to spend more time over here. देख लो एक बारी. आयुष थोड़ा ज़्यादा आ गया दोस्त. Just do this calculation, you'll get it. Okay. हाँ हाँ तिरुपति, that's what I was wondering. Shishir, that is correct in some cases, for sure. Actually, that's correct. Delta H equal to delta U plus delta PV. That is correct. Ayush, which pattern, my friend? Bro, just see some previous year question paper or see a video of my NT Abhyas mock test solving paper. You will realize what's the pattern, bro. Okay. ठीक है, चलो तो ये हो गया. काफी simple, very simple Faraday law. Let's do this particular question. What is the current efficiency? Okay, there's a new term over here. What is the current efficiency of an electrode deposition of copper metal in 9.8 gram of, I'll read the question again. What's the current efficiency of an electrode deposition of copper metal in which 9.8 gram of copper is deposited by a passage of 3 ampere current for 1000 seconds? देखो, theoretically, all right, theoretically, what is the mass of copper to be deposited? Theoretically, what's the mass of copper to be deposited? सोच के देखो. See, we know that copper is copper 2 positive going to copper, है ना जी? Copper 2 positive will go to copper. So we know that 2 into 96,500 coulombs gives me, कॉपर का वेट नहीं दिया इन्होंने, मैं भूल भी चुका हूं. जस्ट अ सेकेंड. Yeah, 63.5 grams of copper. This is something that we know because copper is 2 positive. So 2 into 96,500 gives you 1 mole of copper. Okay, this is 1 mole of copper. Fine. This is something that we've understood. अच्छा ठीक है. So this much gives this much grams of copper. Theoretically, this charge will give you how much copper? Charge कितना है यहाँ पे? 3 into 10,000. तो charge is 30,000. Q is equal to 30,000 coulombs, isn't it? 3 into 10,000, 30,000 coulombs we have the charge. Okay, so यहाँ पे मैं लिख सकता हूँ 30,000 coulombs gives me 63.5 divided by 2 into 96,500 into 30,000 grams of copper. Yeah, calculate this value. This is the theoretical value of copper deposited by this much charge. First calculate, then I'll show you the next step. कितना आ रहा है यहाँ पे? This, when you calculate, will give you 9.87 grams. Okay, this will give you 9.87 grams. Okay, so theoretically mass of copper deposited is 9.87 grams. Actually, copper deposited is equal to 9.87 9.8 grams. So my dear friends, current efficiency is basically percentage. How efficient was the current? You expected it to give you 9.87 grams, but its efficiency was only to give you 9.8 grams. So the percentage will come out to be 9.8 divided by 9.87. Yeah, you expected 9.87, but you got only 9.8. This particular value that you will get is called the current efficiency. As simple as that. Current efficiency is basically what is the percentage of the product that you actually got. ठीक है, तो चलो करके देख लेते हैं. 9.87 divided by 9.8 into 100. Sorry, उल्टा कर बोल दिया मैंने. 9.8 divided by 9.87 into 100. एक second, I'm just doing the calculation over here in the calculator. Yeah, so this comes out to be 99.3%. Cool. Ayush, please do the calculation before giving an answer. Abhishek, yes, NEET is definitely easier than JEE mains in terms of chemistry, of course. 99.29% is the accurate answer. 99.3 also works. Fine. This is what is current efficiency. Got it? Chalo. Now I have a question for you. This is going to be your homework question. I'm going to give you 2 homework questions today. This is the first homework question. Let's read it. I'll give you some hints, then we'll go forward. Okay? A constant current of 30 ampere is passed through an aqueous solution of NaCl for a time of 1 hour. So from this, my dear friends, you can calculate how much current is passed. I'll remind you, 1 Faraday current is equal to 1 equivalent of the substance. Okay. Now the fun thing is that we are talking only about NaCl. Na is Na positive, Cl is Cl negative. So in both the cases, the valency factor is equal to 1. Isn't it? In both the cases, valency factor is equal to 1. So in this particular electrolysis, yeah, a constant current of 30 amperes is passed through an aqueous solution of NaCl for a time of 1 hour. Electrolysis will happen. Yeah, electricity will do something to NaCl. What happens is NaOH and Cl2 gas are produced. Okay? So how to solve this question? Listen to me. Take the step-by-step procedure. I'll give you some hints. You have to try and solve this question yourself. Okay? 1 Faraday current is equal to 1 equivalent of substance. Fine. First of all, you calculate how many Faraday current is there. Okay. First of all, you calculate how many Faraday of current is being given to you. So 30 into 3600 divided by 96,500, that will be your Faradays of current. Yeah. Now this Faraday of current will basically give you 1 equivalent of, X Faraday of current will give you X equivalent of NaOH, and it will also give you X equivalents of Cl2. This is the idea. Okay. X Faraday current will give you X equivalents of NaOH and X equivalents of Cl2, and the good thing is that since both of these are one positive type of species, yeah, your equivalent factor will be equal to 1. Bas, ye dimag lagana. Try to use this amount of brain, you will get the answer very easily. Okay, got it? So this is the hint for you. This is the homework question. Calculate the Faradays of charge and then figure out what are the equivalents of NaOH and Cl2 that will be produced. Got it? Done. Rohit faced some problems, man. I had a flight yesterday at 9 in the morning, SpiceJet. They delayed it to 9 at night. So wherever I was, I didn't have the setup, couldn't take a class. क्या करे भैया, हो जाता है कभी कभी. Movie selection is second drop. Is it good according to your view for JEE? I don't recommend second drop. Okay, personally I don't recommend it. Okay, so this is done. This is your first homework. Please note it down. Giving you 10 more seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. So this question is something that we will need to do a little bit of research for. थोड़ा सा इसके लिए ना research करना पड़ेगा, ठीक है? Have to do a little bit of research. क्या लिखा है यहाँ पे? We have 2 electrodes made of silver dipped in AgNO3 and 2 electrodes of copper dipped in CuSO4. Sorry, yeah. 2 grams of silver is deposited on cathode of first cell. Then, what mass of silver is deposited at the anode? What mass of copper is deposited at the cathode? I'll give you the hint over here. Equivalence of substance 1 deposited in this particular setup is going to be equal to equivalence of substance 2 that are deposited which is equal to, you can have n number of substances like this. चलते जाओ, ऐसे करते जाओ. Equivalence of substance 3 deposited, etc, etc, etc. This hint that I've given you is basically Faraday's second law. How do we calculate the equivalence of any substance? We basically do given weight, which is given over here as कितना दे रखा है? 2 grams of silver है ना, divided by equivalent weight. That's all you have to do. Yeah, given weight upon equivalent weight, and I would remind you that equivalent weight is equal to molecular weight or molar weight divided by the valency factor. Okay, so silver में basically silver is going from Ag positive to Ag, so valency factor over here is 1. Copper में copper 2 positive is going to copper, so the valency factor is 2. So use that information to calculate the equivalent weight, and that's all. It's a very simple question. This is also a homework for you guys. You have to use your brains. It might take you 30 minutes to figure out what is going on behind this question. Do it yourself, please. Okay. Rajesh is saying, can I use unitary method everywhere? Absolutely everywhere, bro. Yeah. Physical chemistry is 90% about unitary method. So karo. Just note this question down and we are done. Okay, Nivas is asking, can we practice JEE level problems for NEET? Absolutely yes, you actually should do that. The Living Tribunal, can you please Google the meanings of the words? This is a chemistry class, bro. Chalo, theek hai, done. There's your homework. My dear friends, congratulations, the class is over. Chapter is finished, everything is done. Faraday's law is pretty simple. I already told you the basic idea behind it. We were already able to solve some questions. 2 homework questions that I've give you, slightly better level of questions. When you do them on your own, no one can stop you from solving any question of electrochemistry. Fine. So this was all about electrochemistry. Now, apart from these 2 questions, one more homework that I have for you, very important, okay, is read the NCERT of this chapter. Please, humble request from my side, read the NCERT of this chapter. If you read the NCERT, your preparation will go very well. And not only read the NCERT, once you've read the NCERT, solve the NCERT as well. Now tomorrow I will not take any academic regular class. I might take some other generic class, maybe some strategy session, maybe some chat session, whatever. So you have tomorrow as well to complete your homework. These 2 questions and reading the NCERT and solving the questions of NCERT. This is something that you can do in one day. Next chapter that we will begin will be on Wednesday, so Thursday. On Thursday, we will begin the chapter of surface chemistry. And with that, our physical chemistry syllabus will be done. Organic chemistry syllabus for 12th class is already covered. Inorganic chemistry for 12th class, Saurav sir is doing it. I think only one chapter is remaining. He will also complete it very soon. And in case you want to join a crash course at Vedantu, just go to the description box down below. There's a link. Join the crash course. We are running it at a very good price right now. You can go and enroll. Okay. Sairam, I can try to do that in some class, man, for sure. But I'm pretty sure you'll be able to do it. And in the chat box, if you guys give me the answers to the questions, you can help each other in the chat box as well. Fine? Chalo, padhiya hai. Rohit, what's your doubt? You can ask me, man. Yeah. I'm just going to chat with you guys for 2 minutes and then we will finish the class. Yeah? Mujhe lag rahi bhook ab. Chem strategy for NEET. Sarvesh, strategy is very simple. NEET ke liye to it's even more simple. Read NCERT, solve all previous year questions and practice some JEE advanced previous year questions. You're done. Basic simple strategy for NEET. NEET questions are very simple, man. बहुत ही simple से straightforward questions आते हैं NEET में. So NCERT, question solving of NCERT, previous year question solving, base done. How to become better? Just solve JEE advanced previous year questions from chemistry. You can go chapter wise. That's basically the idea behind your chemistry prep. Shivani, thank you so much. Arey yaar Murli, I didn't get the time or the thought process to make a new no BS video. Whenever something interesting clicks my mind, I will definitely tell you so. Okay. Anush, you can refer to NCERT. Definitely. Otherwise, physics mein HC Verma will also have thermodynamics. You can check that out. Sairam, try it again. You will be able to solve it. Yeah. Rajesh is saying, which physical chemistry chapter is tough? Technically none, but if you have to ask me, it would be ionic equilibrium because there are so many things happening in that chapter. If you've step by step understood ionic equilibrium, then it should be easy. Okay. Vikas, I have actually made a strategy session on JEE 2022 preparation. It's there on the channel. You can just check it out. In the playlist of our channel, I'll show you where the playlists are. Yeah. So, over here, just go to the playlist section of our channel. It's available in the phone also. And when you go down, kahin to hoga ek playlist. Strategy wala. Ek second. Huh? Yeah. Chemistry strategy for NEET and JEE 2020, 21, 22. So over here you have a strategy session for 2022 as well. It has like all sorts of information. Okay, fine. You can see this as well. Just see one of the strategy sessions and you'll understand what you have to do. Basically. Otherwise, I'll take a fresh session on strategy very soon. Okay, ji? Got it? Mahalakshmi, yes, you can call me whatever you want. Badhiya. Sairam, yes, the first law of Faraday was the one that I explained in the beginning. The second law of Faraday was the one that I explained for this question. That's why I said, please read the NCERT. That's definitely gonna help. Yeah. Cool. Badhiya. Anush, yeah, man, he's a very good friend of mine. Rohit, we'll see. We'll go somewhere in organic chemistry. Chalo. People, that's it from my side. Thank you so much for joining in. In case you want to enroll into Vedantu's longer courses, crash courses, if you want your preparation to become much better, links are in the description box down below. Please check them out. Discount codes, everything description mein hai. I'm sure you are smart enough to go down and check the description box yourself, right? If you enjoyed this class, please make sure you hit that thumbs up button. Stay subscribed because I'm going to bring you a lot more strategy sessions. Surface chemistry is going to begin very soon. And on this channel, we've covered the entire syllabus almost. There are revision classes for the entire syllabus. There are question solving classes for the entire syllabus. And there are lots of test solving classes as well on this channel. So please make sure you stay subscribed and check out all the content that's available in the playlist section, because that, if done properly, is enough to get you through any examination, be it JEE Advanced, JEE Mains, NEET, whatever. Cool. So thank you so much, people. Until next time, take care. I'll see you soon. Bye bye.